Good morning and welcome to my course Basic Electronics Engineering. This course is generally made for BTech degree students of second year. Myself, Gopal Chakraborty, Assistant Professor, Greater Kolkata College of Engineering and Management, Baripur, a college under JIS Group Educational Initiatives. You can personally meet me at college premises, ground floor, physics lab. You can also send me a mail regarding your doubts and query to my given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gisgroup.org. Students, I have a YouTube channel. The link is given here. You can go through my YouTube page for lots of video lessons that I have already uploaded as per your markout curriculum. And if you feel any doubt, any query, feel free to contact me. Now, the corresponding course pages are www.markoutexam.net and www.markoutwb.ac.in. Now, syllabus for this subject is already uploaded in the university website. This syllabus you can download through the link that I have provided here. Now, the title of the course is Basic Electronics Engineering and the subject code is ESECE 301. It is under the category of Engineering Science course. It has a credit 3 lecture per week. For BTech degree students of second year, third semester, we are going to study this course. So apart from all other departments, only the students of mechanical engineering departments have to study this subject as a part of their curriculum for second year, third semester. Now, the topic that I will going to be discuss is basics of Opamp based clipper and clamper circuit. These topics are also under Module 2, that is Operational Amplifier and its applications. Prerequisite for this topic is elementary idea of semiconductor physics. The course objective is to provide an overview of basics of Opamp based clipper and clamper circuit. After completion of this topic, student will able to understand the principle of Opamp based clipper and clamper circuit. Before going to start with today's topic, I will like to remind you that I have already uploaded lots of video on this operational amplifier. So this is going to be the last video on this module. So that's why if you are a new one, if you want to start with this video, I'll suggest you please go through the last 4 or 5 videos related on the operational amplifier, because without knowing the basics of operational amplifier, it will be difficult for you to understand today's class. Because in today's class also you need the idea of using of the basics characteristics of Opamp, also the how you connected the feedback, how you considered the feedback connection, and also the virtual short concept. So that's why in last 2 or 3 videos I have discussed the using of Opamp as a inverting, non-inverting amplifier, logarithmic, anti-logarithmic amplifier, comparator, and I have also discussed lots of other applications of operational amplifier. So in today's video class lessons, I will going to discuss the clipper and clamper circuit. So in generally you can also make a clipper and clamper circuit using diode, PN junction diode transistor, but here we are going to use operational amplifier to do the same operation as done by a positive clipper or negative clipper or a clamper circuit. So I will discuss one by one with necessary circuit diagram, where I will show you how this will operates, and you will see the input and corresponding output graph for a positive clipper or a negative clipper or a clamper circuit. So first one, that is clipper. Wave shaping circuits are the electronic circuit, so which produce desired shape of at the output from the applied input waveform. So this circuit performs two functions. One is attenuate the applied waveform. Second one, alter the DC level of applied waveform. So there are two types of wave shaping circuit. One is called clipper circuit another one is called clamper circuit. So in this video lessons, I will tell you the details about clipper and clamper circuit. Now, as I have already told you, you can make a clipper or clamper circuit using a PN junction diode or transistor. But here I will only discuss about the Opamp based clipper circuit. A clipper is an electronic circuit that produces an output by removing a part of the input above or below a reference value. That means the output of a clipper will be same as that of the input for other than the clipped part. So, due to this, the peak-to-peak amplitude of the output of a clipper will be always less than that of the input. The main advantages of clippers is that they eliminate the unwanted noise present in the amplitude of AC signal. Clippers can be classified into two types based on clipping portion of the input circuit signal. So one is called positive clipper and another one is called negative clipper. So these are discussed in details. I will show you in given below. First one is positive clipper. A positive clipper is a clipper that clips only the positive portions of the input signal. The circuit diagram of positive clipper. Now I will show you. Okay, so this is the circuit diagram of an positive clipping circuit. Here we have used a op-amp and the non-inverting terminal we have placed the input voltage in the non-inverting terminal. And here is the output voltage followed through by a PN junction diode and short with the feedback from output voltage to a inverting terminal. So we haven't used any kind of resistance. We simply short the output voltage with the inverting terminal. Here we have applied plus supply voltage VCC and minus VCC. And we have used two resistance. One is R1 and another one is R2. And we have ground R2 to ground. So this is the basic circuit of positive clipping. Here, so the circuit shown here, a sinusoidal voltage Vi is applied to the non-inverting terminal of the op-amp. The value of the reference voltage can be chosen by varying the resistor R2. Now, if the value of the input voltage Vi is less than the value of the reference voltage V reference, then the diode D1 conducts, and then the circuit given above behaves as a voltage follower. Therefore, the output voltage V0 of the above circuit will be same as the input voltage Vi for Vi less than V reference. Now, if the value of the input voltage Vi is greater than the value of reference voltage V reference, then the diode D1 will be off. Now the op-amp operates in an open loop since the feedback path was open. Therefore, the output voltage V0 of the above circuit will be equals to the value of reference voltage. So V reference for Vi greater than V reference. The input waveform and the corresponding output waveform of a positive clipper for a positive reference voltage V reference is now shown. So this is the input and output voltage signal diagram for positive clipping circuit. You can see this positive of the input signal is clipped here. Here also. Next, the negative clipper. A negative clipper is a clipper that clips only the negative portion of the input signal. You can obtain the circuit of the negative clipper just by reversing the diode and taking the reverse polarity of the reference voltage. So, in this circuit, you have seen a positive clipper. Now I will show you the corresponding circuit diagram. So this is the corresponding circuit. Only we have reversing the p-n junction diode. So in the circuit above, the sinusoidal voltage Vi is applied to the non-inverting terminal of the op-amp. The value of the reference voltage V reference can be chosen by varying R2. If the value of input voltage Vi is greater than the value of the reference voltage V reference, then the diode D1 conducts. Then the above circuit behaves as a voltage follower. Now, therefore, the output voltage V0 of the above circuit will be same as that of the input voltage Vi for Vi greater than reference voltage. If the value of the input voltage Vi is less than the value of the reference voltage, then the diode D1 will be off. Now the op-amp operates in an open loop since the feedback path is open. Therefore, the output voltage V0 of the above circuit will be equals to the value of the reference voltage. So V reference for Vi less than V reference. The input waveform and the corresponding output waveform of a negative clipper circuit for negative reference voltage V reference now I will show you. So here you can see the negative part is clipped, only the negative part of the input signal. So this is the negative clipping circuit output. Next one, that is clamper circuit. Now in the previous part we have discussed about clippers. Now I will discuss about the type of wave shaping circuit that is called clamper. Opamp based clamper A clamper is an electronic circuit that produces an output which is similar to that of the input, but with a shift in the DC level. In other words, the output of a clamper is an extra replica of the input. Hence, the peak-to-peak amplitude of the output of a clamper will be always equals to that of the input. Clampers are used to introduce or restore DC level of the input signal at the output. There are two types of Opamp-based clamper based on DC shift of the input. One is positive clamper, another one is negative clamper. So in this section I am going to discuss one by one the positive clamper and the negative clamper. Positive clamper. A positive clamper is a clamper circuit that produces an output in such a way that the input signal gets shifted vertically by a positive DC value. The circuit diagram of a positive clamper is shown here. Now, this is the circuit of the positive clamper. So here we use the Opamp, and we have placed the reference voltage at inverting terminal and input voltage at the inverting terminal and the reference voltage in the non-inverting terminal. And here at the output we have used a diode, PN junction diode, and we have used two resistors R1 and R2. So in this circuit, a sinusoidal voltage Vi is applied to the inverting terminal of the op-amp through a network that consists of a capacitance C1 and a resistance R1. That means AC voltage signal is applied to the inverting terminal of op-amp. The DC reference voltage V reference is applied to the non-inverting terminal of the op-amp. The value of reference voltage V reference can be chosen by varying the resistor R2. In this case, we will get a reference voltage V reference of a positive value. The above circuit produces an output which is combination resultant sum of the sinusoidal voltage signal Vi and the reference voltage V reference. So that means the clamper circuit produces an output in such a way that the sinusoidal voltage Vi gets shifted vertically upward by the value of the reference voltage. The input waveform and the corresponding output waveform for a positive clamper circuit is shown here. So in this diagram you can clearly see that here you have applied the input signal and here that will be clamped. So this is the positive clamp circuit. For this figure you observe that the positive clamper shifted the applied input waveform vertically upward at the output. The amount of shift will be depend on the value of the DC reference voltage. Now the negative clamper circuit produces an output in such a way that the input signal gets shifted vertically by a negative DC value. So this is the corresponding diagram. In this above circuit, a sinusoidal signal Vi is applied to the inverting terminal of the op-amp through a network that consists of a capacitor C1 and a resistor R1. That means AC voltage signal is applied to the inverting terminal of the op-amp. the DC reference voltage V reference is applied to the non-inverting terminal of the op-amp. The value of the reference voltage can be chosen by varying the resistor R2. In that case, we will get the reference voltage V reference of a negative value. So, in this circuit, above circuit, which is a combination of the resultant sum of sinusoidal voltage Vi and the reference voltage V reference, that means the clamper circuit produces an output such a way that the sinusoidal voltage signal Vi gets shifted vertically downward by value of reference voltage V reference. So, this is the corresponding output. So, here you can see, able to see that output is shifted in a downward, vertically downward, depending on the value of the DC reference voltage. This is the output of the clampers, negative clamper circuit. So these are the reference book that you can refer for your study. Now the evaluation process is same. Students have to appear for 70 marks end semester exam and 30 marks internal exam, out of which 15 for exam, 10 for assignment and 5 for attendance. So all of you have understand to discuss and enjoyed also. Through these video lessons I have completed the module 2 based on Opamp. In next class I will start module 3. So thank you.